Okay, we've got another distance example here. Now, going back to just a graph of a function, we want to minimize the distance from this point here, 3.50, to this square root function. And we can kind of visually see where it would happen, but what is it going to be precisely? Let's figure that out algebraically. So what we need to know is the distance formula. So distance formula, well, what is the distance from a point? It just comes down to Pythagorean theorem. So it's essentially how far across, how far up. You have your change in your x and your change in your y. And, well, the distance would just be found using Pythagorean theorem. So it'll be the square root of the change in the x, which is just x minus, well, in this case, 3.5 is the x coordinate squared. And then the change in the y is just going to be y minus, in this case, 0. So just very simple there. Okay, so we've already got our distance formula written down there. That's what we want to minimize. But we have two variables. We have x and y. However, we know, well, we're given this equation for y right up here. That is just given to us directly. So we have that equation. Let's use that equation. So we know y is equal to root x minus 8. So let's plug that in. So we're going to have x minus 3.5 squared. And then we're going to have y x minus 8. There's no minus 0 anymore, squared. And we can simplify this a little more. Why don't we... let's not expand things out. Let's just leave it. It's going to be not nice if we expand out x minus 3.5. But the square and the square root, that'll nicely work out to just x minus 8 because the square and the square root cancel. Okay. Oh, hold on. I should probably write down the function correctly. It's 8 minus x, not x minus 8. That's why it's opening to the left, not to the right. So plus 8 minus x. Let's take the derivative of this. So d prime of x is going to be, well, square root is just 1 over 2 of that square root. So x minus 3.5 squared plus 8 minus x. And then chain rule. So my chain rule is going to end up in the picture. That's okay. For the chain rule, well, we have the x minus 3.5 squared part. So that's just going to be 2x minus 3.5. And then plus 8 minus x, well, we're going to have a minus 1 from the minus x. All right. And we want to set that equal to 0 because we're looking for the critical points. So we're going to have in the denominator x minus 3.5 minus 1 over 2 x minus 3.5 squared plus 8 minus x. Bit of a full square root there, but that's okay. We're setting this equal to 0. All that matters is really the numerator, so all we need to figure out is when is 2 times x minus 3.5 minus 1 equal to 0. And this is actually pretty easy to solve. Move over the 1 and the 2. So the 1 will be equal to just 1 on the right-hand side, and then divide by 2, so 1/2. And then just add 3/2. So x is going to be equal to 4. Which, I mean, if we look at the diagram, that seems like what it was there. But it's good to be able to confirm things mathematically. The y-coordinate, well, let's see what that is. Y is just going to be 8 minus 4, as in it's 8 minus x, square root of 4, so 2. All right, so we've got our coordinate that, well, appears to be closest. So the distance is just going to be the square root of, what's it going to be, 0.5 squared, because that's 4 minus 3.5, plus 2 squared. And in the end, the distance would be about 2.06. Why are we doing that? Because we still need to compare it to, as always, the end value. So what are the ends like? Always check those. So for the ends, we could start at start a function. And if we look at our diagram, well, what's the start of that function? It's just the point 8, 0. So x equal to 8, y equal to 0. So what is the distance going to be? Well, we have our distance formula. Let's write it out more fully this time. 8 minus 3.5 squared plus, well, we can use that simplified version where we had plugged in our value y. 8 minus 8 squared. And then, well, that's just going to be, the right part doesn't matter at all. All that matters is this 8 minus 3.5 is just 4.5 squared. And square rooting that is just going to be, well, 4.5. Or you could just visually see, going to the diagram, well, that's just a distance of 4.5. Okay. And if we, so we started at x equal to 8, we're going to the left. If we make x go towards negative infinity, well, I mean, I don't have to write well, then, I mean, just visually speaking, distance is going to go towards infinity. It's just getting bigger and bigger. And that we can just see visually. So as we go to the left, we're just getting farther and farther. That's just clear. So therefore, the closest point is, well, what did we calculate? 4, 2 to the function, or to that point. So the closest point is 4, 2 on root x minus 8, or y equal to that, to the point 3.5, 0.